All right? Did you start it? Okay. So, you want to do, what do you guys? Evaporation is cooling. Condensation is a heating event. Don't forget, solid to liquid to gas, those are the phase changes. Solid to liquid. At 0 degrees, solid goes to liquid and is going to gain potential energy, correct? It's going to gain potential energy. That potential energy is called the heat of fusion. When it goes from a liquid to a gas, it's going to gain potential energy, and that's called heat of vaporization, correct? So, when it goes from a gas to a liquid, it's going to lose energy. It's called heat of vaporization, and when it goes from a liquid to a solid, it's going to lose energy, and that again is called heat of vaporization. Heat of fusion. Heat of fusion and heat of vaporization are potential energies that either increase or decrease the internal energy depending upon the direction. Understood? Okay. So, think two things: an event and the environment. Now, you are covered in sweat, water, and that water is going to gain energy from you and give it to the environment. Thereby, you need me?
I mean, no, I'm on duty, but the kids told me that it's too.
They're all in here. They're good. You don't have to worry.
Thank you.
It's not a problem. But it's a cooling event because you got to understand it's relative to the system. You are the system. So relative to you, it's a cooling event because that heat is coming out of you. So understand that it's relative to the system. Evaporation is a cooling event relative to the system. Condensation is a warming event because as water condenses on your body, it's going to give you energy because it was energetic, now it's less energetic, and that energy's got to go somewhere. It's going to be in your body. So when you talk about thermodynamics, it's always the system versus the environment. Understood? So make sure you have the right perspective for cooling and heating events. Okay, just give me a second. Clouds, as they rise from the ground, they will expand adiabatically, decrease in pressure. What happens to the temperature? They're going to expand, do work on their surroundings, and that's going to cool them. Clear? So a cloud will expand, rise, and the temperature will reduce. A pig rolls around in mud to cool off. A dog pants to cool off. They are using the high specific heat capacity of water so that the pig will roll around in mud. Mud is wet. The water will evaporate, take energy from the pig in order to evaporate. Steam will cause more damage steam at 100 degrees Celsius will cause more damage to the skin than liquid water at 100 degrees because the internal energy of steam is greater because it has that energy of vaporization. The altitude, Mr. I can't make tea, I don't know how to do it. The higher your altitude, the lower your boiling point. The more difficult it is to make good tea. You need really hot water to make good tea. If the boiling point is 70 degrees, it's not going to make good tea. Clear? Okay. When snow forms, it's going to give up energy. So the formation of snow and clouds is actually a warming event. Make sure that you understand how to boil an egg in the mountains, how to cook an egg in the mountains. See what happens. Okay? Melting snow, humidity, relative humidity. At a certain temperature, there's only so much water vapor you can put in air. When it saturates, that's it. You can't put any more in. So the relative humidity, if the humidity right now, let's say outside, it could be as little as 15%. That's the relative humidity. That means that at the temperature outside, it's about 100 degrees right now. It's about 35 degrees right now, right? 38, right? Say 40 degrees outside. If it's 20% humidity, relative humidity, that means that only 20% of the capacity of the air to hold water is met. So the relative humidity is the amount of water vapor that's in air relative to the amount that could be in the air. Okay. You have to know the difference and how it works. If you have iron has approximately 1/10 the capacity to hold heat than water does. Just in terms of numbers, in terms of joules, the specific heat capacity of water is 4.18 joules per gram per Celsius. Iron is 0.45, so it's about 1/9, 0.94, whatever it is. Okay. Don't lean on that because you're going to rock the camera. Know what dew is, dew on the ground. Why does dew form on flowers? You're gonna rock the camera if you touch that corpse. Okay. What else? What does mechanical work do to a system? If I do mechanical work on a system, what does it do to the internal energy of of the system I did work on? You have to know. This you have to know. You have to know. You ready? You have to know this. The heat of fusion is 80 calories per gram degree Celsius. The heat of vaporization is 540 calories per, sorry. The heat of fusion is 80 calories per gram, right? If I want to melt 1 gram of water, if 1 gram of water at 0 degrees solid, and I want to make that 0 degree water, I have to put in 80 calories. If I have 1 gram of water at 100 degrees Celsius, and I want to make it 1 gram of steam at 100 degrees Celsius, I have to put in 540 calories. You have to know that. Put it in your outline. Okay. You have to know what the first and second law of thermodynamics is. You have to know what entropy is. You have to know the relationship between Celsius degrees and Kelvin degrees. A Celsius degree is the same size as a Kelvin degree. 0 Kelvin is negative 273 Celsius. Water freezes at 0 degrees Celsius, which is 273 Kelvin. Water boils at 100 degrees Celsius, which is 373 Kelvin. If I want to double the energy of something and find out what the temperature is, you've got to convert to Kelvin before you do the doubling. Okay, do it. Is it going?
Yeah.
All right, so it's 3 grams of steam at 100 degrees Celsius. I'm going to cool it to 3 grams of ice solid at 0 degrees Celsius, correct? So 3 grams, right? So it's going to be 3 times 540 is 1620, correct? And then 1 calorie per gram degree Celsius is 3 grams. So that's 300 calories, right? And then this is going to be 3 times 80, which would be 240 calories, correct? You okay with that?
Yeah.
And that would be that, and then now add that up. What do you got? What do you got?
2,160.
2120?
Yeah. 2,160.
160, sorry, 2160. Okay? Yes? And that should be it. Let's see. Don't forget your efficiency. Can you drop it down a bit? Don't forget your tilt it down. Don't forget your efficiency. Your efficiency. The more efficient engine is the one with the greater difference between the high and low temperature reservoirs. Don't forget how to calculate your efficiency, correct? If I have right? Yes? That's the sink, low temperature, temperature low temperature reservoirs TL and high temperature reservoirs TH. I think that's about it. Don't forget, don't be afraid to utilize this equation. Pressure volume equals the amount of moles, particles, right? Times that's just a constant, times temperature. So P and T are proportional because they're on opposite sides. P and V are indirect because they're on the same side. Get it? Sure?
Yeah.
So entropy, how does a refrigerator work? Okay. That's it. We're done. Thank you.